describing step-by-step multiple choice question exam reliability test in SPSS using the Cronbach's alpha coefficient. Cronbach's alpha, or equivalently called alpha coefficient, was developed by Lee Cronbach in 1951. It refers to how closely related a set of items of an exam. It does assess the reliability of exam items. It measures internal consistency of items in a test that are dichotomous, i.e., correct or incorrect, such as multiple choice questions. Alpha measures the interrelatedness of the items within the test, and the alpha coefficient of reliability ranges from 0 to 1. If all the items are not related, then alpha will be equal to 0, and if all of the items co-vary, i.e. related, then alpha is close to 1. Cronbach's alpha increases as the intercorrelation among test item increases. A test with Cronbach's alpha score of 0.9 or greater have an excellent reliability, and a test with an alpha value less than 0.5 will have low reliability. Cronbach's alpha formula was established based on the KR20 formula, and it can be used to analyze scaled responses such as Likert scaled items or questions. It can be used for continuous variables, and it can be used to analyze the reliability of binary variables such as multiple choice questions. Cronbach's alpha formula or equation is equal alpha is equal to k divided by k minus 1 multiplied by 1 minus the summation of the variances for each individual items divided by the variance for the total score. So k represent the total number of items, the variance I represent the variance associated with each item, and the variance T represent the variance associated with the total scores. In the following table, the Cronbach's alpha range is represented by reliability level. A test that is reliable and have an excellent reliability will have a Cronbach's alpha range between 0.9 and above. A Cronbach's alpha range of 0.8 to 0.89 will have a good reliability. A test with an alpha range of 0.7 to 0.79 will have an acceptable reliability, and a questionable reliability of a test will have a range of alpha between 0.6 and 0.669, and an alpha range between 0.5 and 0.59 will have a poor reliability. An exam or a test that has a Cronbach's alpha less than 0.5 will be or will have an acceptable reliability and will be unreliable test or exam. reliability tests for multiple choice question exam in SPSS using the Cronbach alpha formula. Reliability test measures the internal consistency of items and the scores consistency. If a same group of students repeated the same exam with the same questions, multiple choice questions at different occasions, their scores in both occasions will be similar, i.e. the exam or the test will be consistent and the scores will be consistent and the exam or test will be reliable. So there is a consistency of scores between those two occasions. So reliability test based on Cronbach alpha assess the exam and the test based on the equation below to determine the reliability of the test. These equations equal to K divided by K minus 1. K stands for the total number of questions, then multiplied by a bracket 1 equal within the bracket 1 minus the sum of the variance for each individual questions divided by the variance for the total score. Here in SPSS I have a data extracted from an exam result for 10 students answering 15 multiple choice questions, and the score for each question is recorded as either 1 or 0. 1 stands for correct answer, 0 means wrong answer. So these data here are dichotomous data. That means a binary data, only two options, correct or wrong. And to determine whether these tests that have these questions in it are reliable, so we're going to do reliability tests based on the Cronbach alpha and based on the formula just described shortly. And to do the test, the first step is to calculate the total score achieved by each individual participant or student, and that can be done by combining all the scores for the 15 questions answered by each individual student. And to do that is to click on transform, compute variable, and then in the window for target variable we're going to call it total score, and the total score is the sum of all the scores achieved by each individual student. And to use the command for the sum, we will click on the function group all, scroll down to statisticals, and then in statisticals select the command or the function for the sum. Drag the sum to here, to this numeric expression box, and then insert the variable one by one between those brackets separated by comma. So we're going to insert the first variable and then separated by comma the second variable, and then comma a third variables, and so on until we insert the whole variables that we want to add or combine together. So we need to make sure that we separate the variables with a comma when we enter them. Another comma here. 11, question 11, 12. So we need to make sure that there is always a comma between variables. Right, so if we click on OK, a new variable is generated in a column for a new variable is generated in SPSS, and I'm going just to do some editing on this variable by clicking on the variable view, and then I'm going to decrease the decimal point to 0, and I'm going to convert that measures into scale, and I'm going to center that, make it into the center, and I'm going to reduce the column into 4, so to make it neat and tidy. So now we have calculated the total score for each individual student participated in the exam, and following the alpha equation here, Cronbach alpha, we need to calculate the variance for the total score. And to calculate the variance for the total score for this variables, we click on Analyze, scroll down to Descriptive, click on Frequencies. In the frequencies, we are going to determine the variance for the total score. So we drag the total score to the variable box, click on Statistics. In the statistics box, we're going to select the variance. Click on Continue, as we're only interested in the value for the variance. An output from SPSS generate two tables. One of the tables says that we have 10 participants and the variance for the total score is equal to 24.84. So if we double click on that and then highlight that and select the numbers, copy, and then bring it here to this PowerPoint, and I'm going to place the variance for the total scores in this place here, and I'm going to decrease this by 1 decimal. So we have calculated the variance for the total score. The next step is to calculate the variance for each individual questions and then add them together. To do that, here in this SPSS, we're going to select the data and do a transpose to calculate the variance for each individual question. And the way to do that is to click on Data, Transpose, and on this small window, select Control A, select all, and transfer them into the variable box, and then click on OK, and the data has been transposed in a way that all the questions now are in rows and all the students are now in columns. So I'm going to do a few editing here before I proceed with the further calculation. So what I will do, I'll click on the variable view and I'm going to decrease the decimal into 0. So I'm going to make all the values for 0 decimals, and I'm going to change the measures for each variable to scale. Every one of them, make it scale. And then I'm going to center the data into the center of the columns. So selecting this and then all centers, and I'm going to decrease the column width into make it 4. And another modification I'm going to do is also rename the columns for the students. So to do that is to click on Control F and use the replace function, and I'm going to type VAR0 and replace that with S for students, and I'm going to do that for all the variable. And to do that, I first have to select all the variables, click on replace all, so all the variables has been renamed. Click on close, back again to data view. Now the data looks more neat and tidy. So now we have already calculated the variance for the total scores. Now we need to calculate the variance for each individual questions here, from question number 1 to question number 15. And the way to do that is to click on transform, compute data, and then we're going to call that the variance for the questions. So variance for each questions. And to do variance for each questions, we're going to select the command variance from the function group. If we click on all and then scroll down to statistical, and then in statistical, in the box below, select the variance, drag the variance into the numeric expression, and again we are going to calculate the variance for each individual students. So we're going to use for each individual questions, and if we're going to use the variables from student number 1 to 10, and the way to do that again is to insert the first variable and then separate it by a comma, and we do the same for the rest. Until we reach the S10. If we click on OK, a column will be generated for the variance for each individual, calculated for each individual question. And I'm going to do some editing here for variance, is to make it center and make it scale and reduce the decimal into 0. So I'm going to get rid of this value for the totals. I'm going to keep the decimal by 2, as we are here we having decimals, so we'll retain the decimals, 2 decimal points, so we can see the variance here. This is the variance for each individual questions. Now we need, following this formula here, we need to add all this variance for each individual questions together, and the way to do that is to click on analyze, descriptive, frequency, and there we're going to select the variance for questions, drag it to the variables, click on statistics, and then select the sum, because we are going to add all the variance for all the questions together. So if we click on continue, then click on OK, again the variance for the 15 questions has been calculated and found to be 3.8, and I'm going to select this, or select this, copy it, and or just type it here, 3.8. Now we have most of the component required for calculating the Cronbach alpha ready. So the next step is to divide these figures to find out the product. So to do that, I'm going to use a calculator here. Using the calculator to divide 3.8 over 24.84 equal to 0.152 or 0.153. Then subtract this figure from 1. 1 minus 0.153 equal 0.847. 0.847. Then multiply this figure with k, which is the total number of questions, divided by k minus 1, which is 14. And the total number of the questions are 15 here. So 0.847 multiplied by 15 divided by 14 equal to 0.9 or 0.91. So this figure or alpha value of 0.91 means that the test or the exam is 91% reliable or 0.91 reliable. The value for the alpha or the Cronbach's alpha range from 0 to 1. 0 means that the test or the exam is not reliable, and 1, it means that the exam is extremely reliable. So in this case, 91%, the exam is reliable. So this is the way to perform reliability tests in SPSS for a multiple choice question exam using the formula or the equation for the Cronbach's alpha, which is equal to k divided by k minus 1 multiplied by 1 minus the sum of the variance for each individual questions divided by the variance for the total score to get the value for Cronbach's alpha. So Cronbach's alpha is one of the method to evaluate the exam, the multiple choice exam questions quality.